In this task, a radial basis function based neural network is developed, applying hierarchical clustering to the input data points in order to develop a lock unlock logic of a bank vault. Number of quotients given in the problem statement is equal to 4. So the number of clusters required is also equal to 4. Sigma value is taken as 0.9. Since the search space is large, so zero point 0.9 value of sigma can be taken into consideration without the risk of being overlapped. The 7 card patterns given in the problem statement are taken as 8-bit binary numbers, out of which the first 3 cards are for A, next 2 cards for B, and the last 2 cards are for C. Now, the possible combinations in which A can select any 2 cards out of the 3 cards are performed in line 22 and 23. So, we define A select as permutation of 1, 2, 3. Then the possibility in which A can select any 2 cards from the 3 cards is done in line number 23. Now, in line 26, defining a matrix as unlock codes. Now, we have to update this matrix by all the possible sequences which are going to unlock the lock. Running the for loop for I is equal to 1 to 6, which is the maximum size of the matrix A select. That means these many combinations are possible for A to select the cards. Then for J is equal to 1 to 2 and K is equal to 1 to 2 for B and C respectively. In line 31, the possible unlocking sequences are defined as the unlock code matrix is updated by A is selecting the first 2 cards, followed by B and then C. Further, in line 33, the unlocking code is A is selecting the first 2 cards, followed by C and B. Now, hierarchical clustering is performed in the input data points. For that, first of all, we have to define the distance matrix or the dissimilarity matrix. So in line 42, distance matrix is defined as a size of length of that is maximum size of this unlock codes matrix. That is all the possible combinations which are going to unlock the lock. So we will get a square matrix of size 48 cross 48 as a distance matrix. Now in the next for loop from line 43 to 47, the rows and columns of the distance matrix are updated by taking Euclidean distance of all the points from all the other data points. So the Euclidean distance function is used to calculate that, which is defined in this file. Further, we are defining R matrix in order to keep the track of all the newly formed clusters. And we also have to define a tree matrix in order to draw the dendrogram. The tree matrix will be of size number of points minus 1 cross 3, where all the 3 columns are 4. First 2 columns will contain those points which are grouped together to form the cluster, and the last or the third column will contain the minimum value at which the grouping is done. So, in line 54, we are creating a cell type array by the name cluster of size 1 cross 48, and from 55 to 57 a for loop is run to update the cluster cell by all the possible 48 combinations. That is, the clustering at the first step is done by this. Now, in line number 60, we are creating a structured data type by giving the name data. Now we will run the while loop till all the points are clustered and just one point is remaining. In line number 65, we find the minimum value and its corresponding indices from the distance matrix using the function findMean, which is defined in this file. So in this function, the output variables are minimum value and the corresponding indices of that minimum value, and it will be calculated from the distance matrix. So for that, as we know, in a hierarchical clustering, we have to consider the lower triangular part of the matrix. So the trill command is used to consider the lower triangular part, and then -1 is taken in order to consider the part below the mean diagonal element. Now in order to find the minimum distance, we have to set all the zeros available equal to infinity. So in line 9, we are setting all zeros to infinity in order to find the minimum distance. And then in line 12, the minimum in the lower triangular matrix is calculated, and it is stored in the min12 variable by using the command min. Now, since multiple points may have the same distance, that is why line number 16 is defined. So, after finding the minimum value and the corresponding indices of that value, we are updating the cluster in line number 68. A new array is added in the cluster, and whatever minimum indices point we got, that are grouped together to form the new cluster. And the previously formed and the newly formed cluster points are removed from this cell type array in line number 69. Now we are updating the structure data type that we defined by the name data, and we are storing the minimum value and its corresponding indices as well as the cluster in this structure data type. From line 72 to 76, this structure data type is updated. Now updating the tree as tree matrix as well as the R matrix. So in the tree matrix is updated with the corresponding indices and its minimum value. And the R matrix is updated by removing the newly formed corresponding points which newly form the cluster. Now we have to update the distance matrix. We know when a new cluster is formed, we have to find the maximum distance of all the we have to compare the distance of all the individual points with that grouping points and have to consider the maximum distance into consideration. So in line 85, the distance matrix temp is stored as a temporary variable by finding the maximum distance of all the points row wise and column wise from the indices of that corresponding points which form the new cluster. And then those 2 points which form the cluster are removed from this very temporary variable. Now we have to delete the row and the column from the distance matrix which are form the new cluster. Then the distance matrix is updated with those maximum values that are found in line number 85 and 86. That is, the distance matrix is updated with the maximum values in line 91 and 92. Now we have to find the centers, and in our case, number of Gaussians is equal to 4. So we need 4 centers, which will be in 32 dimensional space, since we are going to insert 4 cards at a time. Now running the loop, if the maximum size of the cluster matrix is equal to 4, then we define the center matrix as of size 4 cross 32. Then running the for loop for I is equal to 1 to 4, the center is calculated by averaging all the possible unlocking combinations that are stored in the cell type array. Finally, we are plotting the dendrogram using the dendrogram command. Now, as per the problem statement, the lock should not unlock for any other sequence other than the mentioned sequence or the possible combinations. So, to check whether it works for the code or not, we are taking 1000 random points. and we are defining a matrix as trials. Taking m is equal to 1000 and running a for loop for 1000 times in line 1 and 4, we are generating a 32-bit binary number, and then we are checking if these 32-bit binary numbers are a member of these unlocking codes, that is all the 48 possible sequences. If they are member, we are considering the numbers only if they are not a member of this unlock code. And then we are updating the trials matrix with all the trials that we have found in line 116. Now we are combining all the correct and incorrect, that is all the trial points that we have calculated, and we combine all them in the all trials matrix. So no, we should get a one value when the sequence is correct. So we should get 1 against all those 48 possible combinations and zeros against all the trials that we have taken into consideration. Now running the for loop for 1 to 1048 times, that is all the correct and incorrect sequences, and then for j is equal to 1 to 4, since 4 Gaussians are available, we are finding the G matrix. So G matrix is the is found at the first layer. Is G matrix is the output of the first layer of the RPF, and it is calculated by taking the Gaussian distance, that is e to the power Euclidean distance between all the trial points and the center point, so divided by 2 sigma square. Finally, we are calculating the weights by taking pseudo inverse of the G matrix with the target, and then the output will be equal to G matrix multiplied with the weight, and we are rounding off the output, and then finally we are calculating the error. So while running this code, So by running this code, we are getting a zero error value. That means the code is perfectly whatever is said, that is the lock will be unlocked for only those possible 48 combinations. So we can see in the output, the output contains all the 1048 points that we have taken into consideration, and we are getting an output of 1 for all the 48 possible 48 sequence for which the lock should open, and 0 for all the other 1000 trial points. And these are the weight values that are calculated. So and these are the 4 centers in the 32-dimensional space. Okay, so that's all. Thank you.